the next one. Actually, I wanted to go here and go back. Okay, so let's choose. This is with sum and difference of angles. Sine applied to a sum, sine applied to a difference, cosine applied to a sum of angles, cosine applied to a difference. Remember, these are identities. These are not a distributive law, right? Sine of alpha plus beta is not sine of alpha plus sine of beta. Don't get confused. And also, I would like to review a problem like this with finding any of these that you want to pick. We've done several examples like this, but let's do one more. Okay, so here are the identities. Anything you want. Anything you want. Identities involving some sine of the sum difference, cosine sine difference, etc. And I think this is page 4, yes. If you don't choose, I will. Okay, I will choose 63. Cosine alpha plus beta divided by cosine alpha cosine beta. They say it equals 1 minus tangent alpha tangent beta. I have the feeling that we did this one, but maybe not. Okay. I will also start on the left-hand side. So left-hand side. And I have to replace this by what it equals to. And the identity is cosine alpha cosine beta minus sine alpha sine beta over this. But this is a very simple situation. How come? This is one term. Every time I see one term in the denominator, I know I'm in business. How come? This over this is 1. This over this, sine over cosine. Tangent alpha, sine over cosine. Tangent beta, I'm done. Right-hand side. Please remember, it's this identity. Cosine alpha cosine beta minus sine alpha sine beta. One term, this over this is 1. This over this, because you cannot simplify in a sum, you have to separate into 2 fractions. This over this is 1 minus this over this, sine over cosine is this, sine over cosine is this, which is exactly the right-hand side. Let's take a moment and see if we have questions on this problem. Anyone, any questions? Okay, let's go back. And yes, please, go ahead.
So you got the tangent alpha tangent beta from sine alpha sine beta divided by cosine alpha cosine beta, correct?
Yes. So sine alpha over cosine alpha is tangent alpha. Sine beta over cosine beta is this.
Okay, thank you.
But just to make sure, let me write an intermediate step. Cosine alpha cosine beta over this minus sine alpha sine beta over cosine alpha cosine beta. If it's not clear, write intermediate step. This over this is 1. This is this piece. This is this piece. Is this better?
Yes, so much better. Thank you.
Perfect. So write it first separately. This over this, which gives us 1, because they are the same. And then this over this, which gives us this. And sine over cosine is that, sine over cosine is this. Different angles, though. Perfect. Other questions? Okay, let me share my screen and move on to the next set with double or half angles. Good. So let's choose from here. Let's see any identities with double or half angle. Okay, so let's choose establish the identity or prove the identity. Any preference? Okay, I will then. I have no idea what to choose. I think we did 56 if I remember correctly. What about 57? Cosine twice theta over 1 plus sine twice theta, they say equals cotangent theta minus 1 over cotangent theta plus 1. I picked this because I have really, looking at it, I don't anticipate or foresee how to get from here, to be honest. So let's start from the left-hand side and see what happens. Cosine 2 theta and sine 2 theta. There's nothing I can do here. Remember, these are two terms. So what are my options here? Not too many. Let me just 1 second check that I copied everything correctly. Cosine 2 theta, 1 plus sine 2 theta, cotangent, yes? Minus 1 cotangent plus 1. Okay. So the denominator is very clear. There is nothing I can do other than, actually, I just realized what this is. By looking at, remember we had an identity a long time ago, which was tangent alpha over 2. Does anyone remember the two identities? We had two identities that were equal to tangent alpha over 2. Anyone remembers them? We proved them actually in class. First of all, we proved them without even knowing that they are equal to this. Anyone remembers those?
Is it 1 minus cosine theta divided by 1 plus cosine theta?
Yes, that's one of them. That's one of them, but I want the other two. You're correct. With a square root. I want the other two that do not have the square root. Anyone remembers them? Here is in our modules, I posted, where is my class? Where is my class? Okay, so in modules, and I recommend you take this with you. I posted a condensed list of identities. So I have to let this for a second. Okay. And here they are. And I recommend you take this with you. .5 and 6.6 identities. So at least if you don't print out anything else, save everything, but at least this should be handy. And this is what I had in mind. And we proved this identity. 1 minus cosine alpha over sine alpha, or theta, it doesn't matter, it has to be the same angle. Sine theta over 1 plus cosine theta. And you're correct, it's the same with this, with the square root. But the square root on top of it, plus or minus. Because it's this ratio, right? So tangent alpha over 2 is this ratio, but with plus or minus in front and the square root. Okay. So this is what I wanted, the sine alpha over 1 plus cosine alpha. How come? Because I was thinking that there is any, let me go back for a second. So 1 minus cosine alpha and sine alpha in the denominator, I'm hoping that something like this will maybe have a connection. Because we can change cosine 2 theta. We have 3 options for cosine 2 theta. Okay, so I may or may not use this, but I just want you to remember that tangent alpha over 2 equals these two, and we proved that in class together. Okay, so let me go back to cosine 2 theta. The options are cosine squared theta minus sine squared theta. 1 over 1 plus, remember this is 2 sine theta cosine theta. The other option will be here as 1 minus 2 sine squared theta over 1 plus 2 sine theta cosine theta. None of these options take me anywhere. So the last option that I can think of is multiplying top and bottom by the conjugate of this. I don't see any other option. So that's my last resource. So cosine 2 theta, we've done this little trick before. 1 plus sine 2 theta, 1 minus sine 2 theta over 1 minus sine 2 theta. So this is 1. There is no need for this, and there is no need for this. Okay, so what happens now? I get cosine 2 theta, 1 minus sine 2 theta. And let's see what I get here. I get 1 minus sine squared 2 theta. Okay. If I change this into one of those, cosine 2 theta, okay. I still don't see how to continue. Let me look at the other side. The right-hand side, cotangent theta minus 1 over cotangent theta plus 1. Okay. Cotangent is cosine theta over sine theta minus 1. And this is cosine theta over sine theta plus 1. Okay, let's see what happens next. Cosine theta minus sine theta over sine theta times cos sine theta. I flipped the denominator already, over cosine theta plus sine theta. Okay. So the fully simplified form of the right-hand side is this. There is nothing I can do. Of course, I'll simplify and I get 1. So now I have an idea, and let me go back to the left-hand side. The left-hand side, once again, was cosine 2 theta over 1 plus sine 2 theta. Okay. Cosine 2 theta is cosine squared theta minus sine squared theta over 1 plus. I'm not really sure what to do with that, but I'm going to change it into this. Okay. I will factor this into cosine theta plus sine theta over cosine theta minus sine theta. And the denominator still stays as 1 plus 2 sine theta cosine theta. Okay. I have the cosine theta minus sine theta. I have the cosine theta plus sine theta. Okay. What do I need to divide by? If you see something I don't, please tell me. If I factor out cosine, it's not going to work. If I change, this was 1 plus sine 2 theta. If I multiply by this, I guess, so this, okay, cosine, I'm continuing here for a second. So cosine 2 theta, 1 minus sine 2 theta, the denominator is cosine squared 2 theta. I'll simplify one of these. And now I have 1 minus cosine 2 theta over cosine, okay. So this is secant minus tangent. And do I get this from here? So it was 1 minus, so 1 was secant 2 theta minus tangent 2 theta. So secant 2 theta minus tangent 2 theta. But how do I get from secant 2 theta minus tangent 2 theta to this? 1 over cosine, okay. Secant 2 theta minus 2 tangent theta, 1 minus tangent square theta. But that's not going to change my secant 2 theta. Again, if you see something I don't, let me know. This was cosine, this is cosine squared. I simplified, 1 minus cosine minus tangent. So this is okay. 1 over cosine 2 theta is not going to change anything because I can't do anything with 1 over cosine 2 theta. Okay. I don't want to waste our time. I will finish this after we finish tonight. I will not let it go. Cosine 2 theta. I don't think I copied anything wrong. I double checked. Oh, oops, where's my? It was cosine 2 theta, 1 plus sine 2 theta. It was indeed cotangent, both of them, minus 1 plus 1.